Good morning, students. Chapter 6, Work, Energy and Power. Yes. In today's lecture, we will see some questions. Here it is. A body of mass 2 kg, initially at rest, moves under the action of an applied horizontal force of 7 Newton. On a table with mu k, that is coefficient of kinetic friction 0.1, means it is rough surface given. Compute work done by applied force, work done by friction in 10 seconds, work done by net force in 10 seconds, and change in kinetic energy in 10 seconds. Change in kinetic energy in 10 seconds. Okay? See, first of all, we will see situation. What is given? A body of mass 2 kg, initially at rest. So, yes, here, mass of object m is equal to, here it is 2 kg. Initially at rest means initial velocity v0 is equal to, it is 0. At rest, moves under the action of an applied horizontal force of 7 Newton on a table with mu k is equal to 0.1. With mu k is equal to 0.1. What is meaning of this? See, if it is stable. If it is stable. Initially, block is at rest. Initially, block is at rest. Yes or no? Yes. After that, under the action of applied horizontal force of 7 Newton on a table, it is under motion. Means, in this situation, let F external force is applied in this direction. F. What is value of F? Yes, F is equal to, it is 7 Newton. That is external applied force. On a table with mu k is equal to 0.1, means it is rough surface, and yes, on the rough surface there is friction force. So yes, that friction force is acting in opposite direction of its motion. Friction force is acting in opposite direction of its motion. Clear about this? Clear about this? Okay, so yes, that friction force is acting in opposite direction. So first of all, we will find what is friction force. See here, friction force. Friction force. We know that what is friction force? F. F is equal to, it is mu k into n. And what is mu k? Yes, mu k you are given. What is n? See, on this block, mg is acting in downward direction, while normal force is acting in upward direction. Block is moving in horizontal plane. Block is moving in horizontal plane. Block is not moving along this vertical plane. So, along this vertical plane, it is in equilibrium, means forces acting in upward direction is equal to forces acting in downward direction. So I can write n is equal to mg. So here it is mu k, n is equal to, here it is mg. Clear about this? So yes, mu k, it is 0.1, yes you are given. M, that is 2, and g, it is 9.8. So 0.1 into 2 into 9.8. If you calculate this, you will get 1.96 Newton. 1.96 Newton. So see, now on this object, applied force F is acting in this direction, while friction force is acting in opposite direction. Now next, yes, a body of mass 2 kg, initially at rest, under the action of applied horizontal force on a table with rough surface, so friction force. Okay, now we have to calculate what is work done by applied force in 10 seconds, work done by friction in 10 seconds, work done by net force in 10 seconds. What is equation of work? Work is equal to force, work is equal to F dot D. Yes, work is equal to, we know that work W is equal to, it is F dot D. Yes or no? Work W is equal to, it is F dot D, where F is force and D is displacement. So first of all, we have to find displacement in 10 seconds. Because in each and every question, you have to find what is work done by applied force, what is work done by friction force, and what is work done by net force in 10 seconds. In 10 seconds. So yes, first of all, we will find what is displacement in 10 seconds. But to find displacement, if you use equation x is equal to v0t plus half at square. X is equal to v0t plus half at square. See, for example, here it is. For example, here it is. If I want to find displacement in 10 seconds. Displacement in 10 seconds. Okay, that is T is equal. Then what is equation? Yes, equation is, it is v0t plus half dt square. Initial velocity is 0, so yes, this term is 0. Half t you have to put 10. But what about a? Acceleration of this block? You are not given, and you cannot put g. You cannot put g because the object is moving in horizontal plane. Clear about this? So yes, first of all we have to find value of a. How to find this value of a? How to find this value of a? See, here it is. Here it is. See, on this block, in horizontal plane, two forces are acting, F and F. And I am assuming that object is moving with acceleration a in this direction. With acceleration a in this direction. Clear about this? Yes. Under the effect of applied force F, that is capital F, and friction force, I am assuming that block is moving in horizontal direction with acceleration a. With acceleration a. So yes, here I have assumed its acceleration. Let acceleration of block is a. So see, as it is moving with some acceleration, I can write sigma f is equal to ma. I can write sigma f is equal to ma. Yes or no? Yes, I can write sigma f is equal to ma. Yes, I can write sigma f is equal to ma. Now numbers of force acting on block, f and f. So it is simple. Yes, here it is. F minus f is equal to ma. So therefore a is equal to f minus f upon m. F, applied force 7. What is friction force? 1.96. 1.96 divided by what is mass? It is 2. Yes or no? F minus f, 7 minus 1.96, 7 minus 1.96, it is 5.04 is equal to, it is 5.04. So it is 5.04 divided by 2. So yes, that answer is, it is 2.52 meter per second square. 2.52 meter per second square. So it is acceleration of block. It is acceleration of block. Clear about this? Yes, it is acceleration of block. Any doubt? Okay. So yes, what is acceleration of block? It is 2.52 meter per second square. Now we can easily find what is displacement. See, displacement in 10 seconds. So d is equal to a is initial velocity 0 plus it is half a, it is 2.52, t, it is 10. Okay, so yes, if we find displacement, we will get displacement d is equal to, it is 126 meter. What is displacement in 10 seconds? It is 126. Clear about this? So yes, first of all, we have to find what is friction force, then we have to find what is acceleration, then we have to find what is displacement in 10 seconds. Now we can easily calculate these three questions, first, second and third. See, first, work done by applied force in 10 seconds. Work done by applied force. Work done by applied force in 10 seconds. In 10 seconds. W by applied force. See, applied force, it is F. And see, displacement of block, it is also in same direction. Yes or no? Block is displaced in this direction. Block is displaced in this direction. Displacement is in this direction. So see, from figure, force and displacement, they are in same direction. So I can write it is Fd cos 0. What is value of F? Applied force 7. Applied force, only this applied force, it is 7. What is D? It is 126, and cos 0 means it is 1. So 7 into 126. 7 into 126, it is 882. It is 882. Clear about this? Clear about this? Okay. Now work done by friction force. See, here it is work done by friction in 10 seconds. Work done by friction. Work done by friction in 10 seconds. So yes, again it is Wf is equal to now work done by friction force. See, displacement is in this direction, but friction is acting in opposite direction. So what is angle between friction force and displacement? What is angle between friction force and displacement? Yes, it is 180. So here it is small f, here it is d cos 180. What is value of F, that is friction force? Here it is 1.96. 1.96. What is displacement? 126. And cos 180 is minus 1. Cos 180 it is minus 1. Clear about this? Yes, cos 180 is minus 1. Cos 180 is minus 1. Okay, so yes, 1.96 into 126 into minus 1 is equal to, it is minus 247. It is minus 247. Clear about this? So yes, it is work done by applied force. It is work done by friction in 10 seconds. Now, third question is, what is work done by net force? What is work done by net force? So yes, now we will see what is work done by net force. See, here it is. Work done by net force. Okay. Work done by net force. Work done by net force. W net is equal to, net force is acting in this direction, and net force is nothing but, it is F minus F into V cos 0. What is net force? Applied force is acting in this direction, friction force is acting in opposite direction, so net force is F minus F, F minus F. And what is F minus F net force? It is 5.04. It is 5.04. Displacement is 126. Cos 0 it is 1. So yes, you will get this answer 635 Joule. So what is W net? It is 635 Joule. Or you can also find this work in W net by subtracting these two words. This work is in direction of displacement. It is in opposite direction of displacement. So if you add them, 882 Joule minus 247 Joule, you will get 635. You will get 630. Clear about this? Okay. So yes, question number 1, 2, 3 over. Now last question. What is change in kinetic energy in 10 seconds? Chalo, what is change in kinetic energy? What is initial kinetic energy? It is simple. Initial kinetic energy. Initial kinetic energy. Ki is equal to, it is half m v0 square is equal to 0. Yes or no? Now how to find final kinetic energy? Final kinetic energy. Final kinetic energy Kf is equal to half m v square. Where? What is v? What is v? Yes, what is v? V is speed in 10 seconds. Now how to find speed in 10 seconds? See, yes, we have equation. V is equal to V0 plus A. V is equal to V0 A. It is 2.52. Yes, what is value of A? Is 2.52. And T, here it is 10. So V is equal to, it is 25.2 meter per second. Clear about this? Now put value in this equation. So is equal to, it is half m, it is 2. Yes, m is equal to, it is 2, and v square, which is 25.2 whole square. And if you calculate this, you will get nearly 635 Joule. You will get nearly 635 Joule. So what is change in kinetic energy? Change in kinetic energy. Change in kinetic energy, delta K is equal to final kinetic energy minus initial kinetic energy. Final kinetic energy is 635, initial it is 0, so it is 635. And see here, change in kinetic energy delta K is equal to 635 Joule. Work energy here, that work done by net force is equal to change in kinetic energy. Work done by net force is equal to change in kinetic energy. Clear about this? Okay. So yes, it is one question which is based on this work energy. Clear? Yes. Here, see, understand, to find final kinetic energy, you have to use this equation, that is half m v square. But v is not given. So first of all, you have to find value of v, that is speed in 10 seconds. Clear about this? So yes, it is one question which may be asked in 4 marks. Clear? Now next question, see, the potential energy of 1 kg object free to move along x-axis is given by ux is equal to x raised to 4 divided by 4 minus x square by 2. If mechanical energy is 2 joule, if mechanical energy is 2 joule, find its maximum speed. Find its maximum speed. See how to find this question. The potential energy of 1 kg object means mass is given 1 kg. Free to move along x-axis is given by ux, it is potential energy. If mechanical energy means it is E is equal to, it is 2 joule. Okay, then find its maximum speed. See, maximum speed, if speed is maximum, then kinetic energy is also maximum. And when kinetic energy is maximum, potential energy is minimum according to law of conservation of mechanical energy. Okay, so yes, here if speed is maximum, kinetic energy is also maximum, and therefore potential energy is minimum. So yes, how to write this equation of E, that is total energy? E is equal to it is half, or I can write K maximum plus U minimum. So E is equal to, it is half M V maximum whole square plus U minimum. See, to find this V maximum, we have to find what is V maximum. M, mass is given, E is given. What we have to find? Yes, we have to find what is U minimum. What is minimum potential energy? What is minimum potential energy? Okay, yes, it is equation of U. X is equal to x raised to 4 upon 4 minus x square by 2. So, it is equation of potential energy. Potential energy Ux is equal to, it is x raised to 4 divided by 4 minus x square by 2. Now see, Ux, why to write Ux? Because U, that is potential energy, is function of x. U, that is potential energy, is function of x. As value of x changes, U also changes. Clear about this? Okay. Now, potential energy is minimum. That is one mathematical concept. If potential energies, we say, if potential energy is minimum and it depends on x, it is function of x, then differentiation of potential energy with respect to x becomes 0. If a quantity is maximum or minimum, then on which it depends with respect to that, differentiation is 0. Here potential energy is function of x. 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 So d upon dx, differentiation of potential energy with respect to x, it becomes 0. D upon dx of u, it becomes 0. Differentiation of potential energy with respect to x becomes 0. Yes, this is one mathematical concept that we have to remember. If one quantity depends on another quantity, then with respect to that quantity, differentiation of this quantity will become 0. U depends on x, so differentiation of u with respect to x will become 0. Now, d upon dx of u, what is value of u? Yes, here it is x raised to 4 upon 4 minus x square by 2 is equal to, here it is 0. Okay, now you know differentiation, how to differentiate. So therefore x is to 4, its differentiation is 4x cube divided by 4 minus, what is differentiation of x square by 2? X square, it is 2x, and 2 as it is equal to, here it is 0. Clear about this? Clear about this? So now 4 cut, 4 cut, 2 cut, 2 cut. Now how to simplify this term? See, I am taking x common, or x cube minus x is equal to 0. Now I am taking x common, then it is x square minus 1 is equal to 0. Clear about this? So therefore x is equal to 0, or x square minus 1 is equal to 0. So yes, x is equal to 0, or x square is equal to 1. So x is equal to plus or minus 1. So yes, we have three values, x is equal to 0, x is equal to plus or minus 1. So now out of this three value of x, we have to find, okay, for which value of x potential energy is minimum. Potential energy is minimum. Now out of these three values of x, we have to identify, okay, for which value of x potential energy is minimum. See, out of which value? So first of all, in equation of potential energy, first of all I will put x is equal to 0. Okay, if for x is equal to 0 means u 0 is equal to, in equation of potential energy, we have to put x is equal to 0. So here it is 0 raised to 4 upon 4 minus 0 raised to 2 divided by 2 is equal to, it is 0. So for x is equal to 0, what is potential energy? It is 0. Now for x is equal to plus or minus 1, for x is equal to plus or minus 1, because we have both terms having even power, so yes, for x is equal to plus or minus 1, u plus or minus 1 is equal to, yes, here it is plus or minus 1 whole square divided by 4 minus here x is equal to plus or minus 1 whole square divided by 2. So here it is 1 by 4 minus 1 by, yes, it is 1 by 4 minus 1 by 2. Clear about this? 1 by 4 minus is 1 by 2. So what is 1 by 4 minus 1 by 2? What is 1 by 4 minus 1 by 2? If you want to calculate, then yes, you can calculate this. Simple. Okay, 2 minus 4 divided by 8. So it is minus 2 divided by 8. It is minus 1 by 4. So u plus or minus 1. It is minus 1 by 4. Now see, for x is equal to 0, potential energy is 0. But for x is equal to plus or minus 1, potential energy is minus 1 by 4. So which value is minimum? Which value of potential energy is minimum? Yes, this minus 1 by 4, not 0. So here u minimum is equal to minus 1 by 4. U minimum is equal to minus 1 by 4. So now we have to put this value in equation, that is E is equal to K maximum, that is half m V square maximum plus U minimum. What is mechanical energy? It is 2. It is half. What is value of mass? Mass is given, yes, it is 1 kg. Okay. Here it is V square maximum. And what is value of U minimum? It is minus 1 by 4. It is minus 1 by 4. If you take this term this side, then it is 2 plus 1 by 4 is equal to, it is V square maximum divided by 2. Now how to simplify this? 4 into 2, it is 8. 8 plus 1, it is 9. So it is 9 by 4 is equal to, it is V square maximum. It is V square maximum divided by 2. It is V square maximum divided by 2. Now this 2, this 2. Yes or no? Yes or no? So it is 9 by 2 is equal to, here it is V square maximum. And to find V maximum, if you take square root from both sides, then V maximum is equal to 3 upon, V maximum is equal to, it is 3 upon, clear about this? Okay, so yes, it is one question. Yes, this concept is new for you. Therefore, minimum and maximum value of some quantity, you have to take differentiation with respect to which on it depends is equal to 0. Clear about this? So yes, it is one question which is based on mechanical energy, total energy. Clear about this? Yes, again, yes friends, this chapter 6, work, energy and power is important. How to apply law of conservation of energy, how to apply law of conservation of momentum, okay, and how to solve questions. This chapter is important. Clear? Watch regular videos, okay, or if you have any doubt, then contact me. And yes, do like, share and comment our videos.